So we're going to move on to coding data now. Why do we bother coding data, and what is it? Well, when we code data, it's normally to make data slightly easier to analyze, and we're making changes to all the individual data points. So we're either adding, subtracting, multiplying, or dividing by some constant number, or we might be doing several of those. It might be, say, adding and multiplying to change all the data points. For instance, an example when we do this is when we have different units, and we kind of implicitly do a coding. For instance, changing from pennies to pounds, we do a divide by 100, which is effectively coding the data. Or if we convert from millimeters to meters and we divide by 1,000, again, it's a coding. And I've got an example for us here. So here's our original data, and I'm going to apply some coding to it. Now these are our x's here. This is our original data. So this is the original, or we could call it the uncoded data. And y is our coded data. Okay, now what I've said here is I'm going to take 100 off each of the data points and then divide by 2. So let's take an example. Let's take that 102 and apply the coding. So I'll do 102 minus 100 divided by 2, which is 2 over 2, which is 1. So the coded value is going to be 1. And you can see all the coded values there. So each of those numbers has been coded onto these numbers. You can see these numbers are a lot smaller. They're a lot easier to analyze. Calculating the mean of this first set of data, the x's, is not difficult, but it'll take a bit longer. Whereas I could actually find the mean of this coded data in my head. If we add all these up, we get 25. Divide by 5, and the mean of that's 5. So you can see it just makes things often easier to analyze by coding the data. So let's have a look at another example. This time my coding is I do 3 times the uncoded value. Remember, this x is the uncoded, y is the coded. So I do 3 times the original data and add 25 to it. So let's say we've got, this is our original data. When we code it, well, let's take an example first. This 13, for instance, we should get 13 times 3 and add 25 on. So we should get 64. And there you can see that value there. So that's just another example of coding. You need to be able to both code data and uncode the data. So when we uncode the data, we need to swap this formula around. When we uncode it, we're changing the y's, the coded data, back into x's. So in this case, say we wanted to go back, what we have to do is rearrange this formula to make x the subject. So I can bring the 25 across, and I can divide by 3. And that's my formula for uncoding the data again. So if I take that 64, for instance, down here, plug that in, and simplify it, I get x is 13, which was the original data point, yeah, the uncoded data point. So you need to be aware of how to code data using a formula given to you and uncode it. And all you do is rearrange the formula and then input your numbers. Nothing too tricky. Well, how does the coding affect the mean and the standard deviation? Well, the mean is affected by basically anything we do to the data. If we add anything to it, or subtract, multiply, or divide, we're going to affect the mean. I'll give you an example here. Let's say this is our original data, and you can figure out the mean if this is 110. All we do is add them all together and divide by 5. Say we apply this coding to it. So we take 100 off each of the numbers and then divide by 2. Take this 112, for example. Take 100 off it, divide by 2. We should get 6. So we're just going to apply that coding to it. What we're wondering is, how does that affect the mean? And we're actually going to use that formula to work out how it's affected, and I'll come back to that in a second. Here's the coded data in the bottom left. And there's the mean of the coded data. Now you could get that by, if you have the coded data, add all these together. I actually did this just previously. You get 25. The mean of the coded data is going to be 25 over 5 is 5, as we found here. But without actually working that out, I can figure out how it's affected by looking at what coding I've done and applying that same formula to the mean. So for instance, to find out what the mean of the coded data is, I take the mean of the uncoded data, which was 110, and I just do exactly the same thing to it. I take the 100 off and divide by 2. That gives us 10 over 2, which is 5. Okay, so actually I can work out how the mean is going to be affected by doing that coding. I don't have to code it and then work out the mean again. I can just take the formula we used to code it and then figure out what's going to happen by using this. You need to be able to do this because sometimes you'll be asked how it's affected without actually being given numbers. So you might just be told a set of data is coded by dividing all the numbers by 2. How is the mean affected? Okay, the mean would be affected just by dividing by 2 as well. Okay, so all we do is apply the same formula but with these bars on top, which mean we're using the mean. Okay, so the mean is affected by anything we code it by. So if we multiply or subtract as we did in this case, or divide as we did in this case, or if we add, the mean's affected by all of those. So we just apply the formula to see what's happened to the mean. It's a different story for the standard deviation. It's only affected by multiplications and divisions. Okay, it's completely unaffected by additions and subtractions. It's all because of what standard deviation is. It's all about how spread out the data is. If I add a number on, the data is still just as spread out. If I take some data and add 100 onto all the values, the data is still exactly as spread out as it was before. It's just a bit higher up. It's just all moved up by 100. Okay, it's not been, how spread out it hasn't been affected. It's the same if I subtract numbers off it. However, if I multiply or divide, it will be affected because if I multiply, things tend to get more spread out. If I divide, things tend to get less spread out. So your standard deviation only affected by multiplications and divisions, not additions and subtractions. So let's have a look at a quick example. You can work out and have a go because we know how to calculate the standard deviation now. The standard deviation of those 5 numbers is 5.2. If I code it using the same coding as I did in the previous section where I was doing the mean, now we said it's not the standard deviation is not affected by additions or subtractions. So this bit here is not going to affect it. So we'll say won't affect standard deviation. That divide by 2 will affect it. Okay, it is affected by divisions. So actually, to find the standard deviation of the coded data, SY, all we do is that divide by 2. You see how the minus 100 disappear because it isn't affected by it. So even without coding the data first, I can tell you that the standard deviation of the coded data is going to be 2.6. It's going to be half of that 5.2. I'm just dividing by 2 there. Okay, that's our coded data that we found last time. And apologies, that should read SY is 2.6. So the standard deviation of the coded data is just half it. It hasn't been affected by that minus 100. Can you see if we did apply the minus 100, we'd get a negative number. Standard deviation is never negative, neither is variance. Okay, doesn't make sense as a negative number. So bear that in mind if you're ever sanity checking your values, but it's only affected by multiplications and divisions.